So in this lesson, we're going to talk about the transformations of linear graphs. All right, so let's start off with our equation here. So our equation here is y equals a times f of bx minus h plus k. The a term in this equation represents your vertical stretch or your shrink, depending on whether a is greater than 1 or in between 0 and 1. The a term also will tell us whether there's a reflection over the x-axis. If the a is negative, there will be a reflection over the x-axis. The b term will give us the horizontal stretch or shrink. And the b term will also, if it's negative, will be a representation of a reflection over the y-axis. And we'll see some examples of these soon. F of bx minus h, all right, the formula is minus h. The minus h will be a horizontal shift to the left or right. So if you have minus 5, it's actually to the right 5. If you have an equation where you have f of x plus 5, that plus 5 came from f of x minus negative 5. So that negative 5 will be a shift to the left, and we'll see some examples of those coming up. And then the plus k at the end, that's your vertical translation or vertical shift going up or down depending on if it's positive or negative. Alright, so let's take a look at these individually. Our first one, we have a horizontal translation. Okay, so we have y equals f of x minus h. So when you have this quantity, x minus h, inside, this is a horizontal translation. So if my graph, my original function is f of x, okay, which is this one in black, my line, my new equation, g of x, is f of x plus 2. So the plus 2 inside the parentheses is going to be a horizontal shift, either to the right or to the left. But remember, my equation is f of x minus h. So in order for me to get this plus 2, this must have been f of x minus negative 2, which is how I got the x plus 2. So this minus 2 is a shift to the left of 2 units. So f of x plus 2 is a shift to the left of 2 units. So if I take any coordinate or all the coordinates and I just shift them all to the left 2 units, I'll get the new line of f of x plus 2. Alright, so the next horizontal translation is this one. Same concept. This is f of x equals 3x plus 2, but now I have g of x equals f of x minus 3. So my original function here is in black. A minus 3 on the inside is actually a horizontal translation to the right 3 units. So if I just take my y-intercept, I move every 1, 2, 3 points to the right. Every other point will move to the right as well. So this line here in red is the new graph, or g of x, in terms of f of x. So the x minus 3, horizontal translation to the right. Back to the other graph, f of x plus 2, horizontal translation to the left. They go their opposite ways. So for a vertical translation, your equation is y equals f of x plus k. Okay, so now that k is on the outside. That's the difference between the vertical and the horizontal. So my original function again is f of x equals 3x plus 2. H of x is going to be f of x minus 3. So again, I'm going to take this function, and I'm going to take my y-intercept, and I'm going to go down 3 units. 1, 2, 3. So this is a vertical translation of 3 units down because of the f of x minus 3 in the back. Not inside the parentheses, separate from the parentheses. I'm affecting my y-coordinate, and everything will go down 3. Reflection over the x-axis, okay? So your equation is y equals negative f of x. All right? So when the negative is on the outside, what I'm really doing is I'm making, so if you look at the tables here, you have x f of x and x m of x. When the negative is on the outside, I'm really just changing all the values of the y values. So all the y values that are negative now become positive. So a negative 1 becomes a positive 1. A 2 becomes a negative 2, and a 5 becomes a negative 5. When I swap equations, so if I have negative 1, 1. So here's negative 1, 1 in red for my first coordinate. And in blue, negative 1, negative 1. Oh, that was negative 1, 1. Sorry. This one should have been down here. Negative 1, negative 1. And in blue, it's negative 1, 1. What's the difference between the red and the blue dot? What axis do they reflect over? Yeah, they reflect over the x-axis. So when you're negative is on the outside of f of x, this is a reflection over the x-axis. Right? Because all my y-coordinates are changing from positive to negative. When the y-coordinates change, it's a reflection over the x-axis. So I'm just going to plot the rest of the points. So 0, 2 here I have, 0, 2 in red, and 1, 5. 1, 2, 3, 4, 5. So these are my lines on f of x. I'm going to do the transform, or I'm going to make all my y values negative. So negative 1 and negative 1, 1, 0, negative 2, and 1, negative 5. So now if we notice that, then this graph will look something like that. And this will be a reflection, again, over the x-axis. Next one, reflection over the y-axis. Okay, so now you have y equals f of negative x. So the negative x is on the inside. So now, all I'm doing, so again, I'm going to graph my coordinates here. And if you notice on this one, it's my x values that are changing signs. So now when I have my x values changing signs, so if I want to graph these, so I'm going to do f of x in red here. So negative 1 again, 0, 2, and 1, 5. And then if I do this one in blue here, x and m of x, so this is 1, negative 1, so here's 1, negative 1. So notice what's happening between the red and the blue here. What axis are they reflecting over?
The y.
Yeah, now they're reflecting over the y-axis. So 0, 2. 0, 2 stays the same. Notice that they're reflecting over the y-axis, so the y-intercept didn't change. And then negative 1, 5 will be here. And then this line would look something like, not that one. Something like that. Alright, so for horizontal stretch or shrink, okay, your equation is y equals f of ax, okay, versus a vertical shrink, or stretch or shrink, which we'll get on the next slide. The a is on the outside. Alright, so this is the a on the inside of the parentheses. Y equals f of ax. So my function is f of x equals 3x plus 2, p of x equals f of 2x. What I want you guys to realize here, okay? So if we forget about the equation for a second, we'll just concentrate on this line. What kind of slope does this red line have? What's the slope of this red line?
0.
Yeah, the slope is a flat line, so it's 0 slope. So what's happening to my a value as this slope, as the line starts going like this, or starts moving in this manner? Yeah, the a's increases. So this could be a slope of a is 0, a is 1, a is 2, a is 3, a is 4. So as my a gets higher and higher and higher, my line is getting steeper and steeper and steeper. With me? Okay. If this is a horizontal stretch, where does it pivot? Does it pivot on the x-axis, on the x-intercept, or on the y-intercept? What does not change if it's a horizontal? On the y-intercept. So it's going to stay on the y-intercept. So this line is going to move around this y-intercept, okay? So it's just going to go around and around wherever it is, depending on the slope. So right now, if this is my slope here, right? If I increase, now what I want you guys to take notice of is this distance here that I highlighted. Look at the distance from the line to the origin, okay? When my a value increases, right, a number greater than 1, so in this case, this has an a value of 2. Is my slope going to increase or decrease? So that means my slope is going to get steeper. What's happening to the line in comparison to the origin? It's getting closer to the origin. So as I increase the a value here, this line is getting closer and closer to the origin. So I'm shrinking the distance from the origin to the line here. So when my a value is less than 0, so this would be an example of a horizontal shrink. Right? Because the a value is increasing. Again, the a value is increasing. As my a value increases, the distance of the red line to the origin is getting smaller and smaller and smaller. It's shrinking, it's shrinking, shrinking because my a value is increasing. So as a is greater than 1, it's a horizontal shrink. So again, looking at this one, this is f of 1/2 x. Okay, so now my a value is between 0 and 1. So when my slope is decreasing, my line is going to start to descend or get lower. But notice the distance of the red line to the origin as my a value becomes smaller and smaller and smaller. So as it becomes smaller and smaller and smaller, the distance between the red line and the origin is doing what? It's increasing, so this is a description of a stretch. So this one would be a horizontal stretch. All right, so the next one, this is a vertical stretch or shrink. Okay, let's explain the difference. So this one is y equals a times f of x. So notice your a term is on the outside compared to being the a terms on the inside. So if you have a vertical stretch or shrink, you need to know where it pivot points. Where's the pivot? So what doesn't change on a vertical stretch or shrink? The x-intercept does not change. Okay, so the x-intercept will stay the same, and it's not going. So this line is going to pivot around the x-intercept. So it's always going to follow that same point and then move around or wherever it has to go. All right. So now I have 3 times f of x. So what's happening to my slope? It's increasing or decreasing, or what's happening? Yeah, what's going to happen if I multiply by 3? Yeah, my slope is going to start to increase. Okay, so your line is going to get steeper and steeper and steeper. So now look at your line now, right? So if this is my slope, let's say this is my original line, and look at the distance between the line, this line, and I'm going to go here in purple, the slope between, let's say, this point and that distance to the origin. What's going to happen as I increase my slope? Is that distance going to increase or decrease? Yeah, so now this distance is going to increase because now it's getting further and further away from the origin. Okay, so if this gets further and further away from the origin, is this distance shrinking or stretching? So as for a vertical transformation, as my a value gets bigger and bigger and bigger, this becomes a stretch. So my apologies, it should be a vertical stretch, not a shrink. So this indeed, as the a value is getting bigger, the line is getting further and further away from the origin or the x-axis, this representing a vertical stretch. Alright, so vertical stretch or shrink on this one, again, same equation, y equals af of x. This time I have a 1/3 in front of my equation. So my slope here, again, my pivot point is going to be my x-intercept. As my 1/3, as I have 1/3 affecting my slope's going to start to decrease. As my line starts to decrease, it's going to get closer and closer to the origin or closer and closer to the x-axis. And if it gets closer and closer, this becomes a shrink. Yes, this becomes a vertical shrink.